Welcome to the video on titration of an unknown acid lab explained. This is part 2 of the video. If you have not seen part 1, you need to go back and watch part 1 because we're going to continue where we left off. Alright, in the first part of the video we talked about the preliminary titration, also known as the indicator titration, and the purpose of that was to determine the equivalence point for the titration of our unknown acid and the 1 molar sodium hydroxide solution, and also to calculate the mass of acid needed to use 20 milliliters of sodium hydroxide. So we ended here where we had calculated the mass of acid that that we need for 20 milliliters of sodium hydroxide by setting up these proportions. So the mass we found was 3.5, and to bring it to 3 sig figs, 3.51 grams of the acid that I'll need for run number 2. Okay, so we can, we'll use that amount when we do run number 2. But before we do it, I want to talk about the purpose of the pH titration, which is run number 2. The purpose is to acquire the data for the titration curve so that we can determine the pKa and the identity of the unknown acid. And when I say the data for the titration curve, we are going to need the pH and the volume of sodium hydroxide added. So I've already set up a spreadsheet so that I can enter my data in. The procedure is to weigh out the amount of acid that we calculated previously. So in this case, it'll be 3.51 grams, dissolve it in 50 milliliters of water, perform the pH titration, plot the volume of sodium hydroxide added versus the pH, and then use that plot to determine the pKa. Now, an important note is that when you're performing a pH titration, you want to control the amount of base that you're adding. So if you look at steps 8 through 11 in your document, they tell you the portions of sodium hydroxide you should be adding depending on how far you are from the endpoint that you determined in run number 1. That was the indicator titration. So this chart here essentially summarizes the information that is in that step. When you are, so the first thing we're going to do is we're going to add like 2 milliliters to the 2 milliliters of base at a time. And that is up until we add about 17 milliliters of the base. So let's say the initial volume on our burette reading is 5, then we're going to add 2 milliliter portions until we get to 22 milliliters. So roughly around 22 is when we're going to say, oh, let's stop adding 2 milliliter portions. From then we're going to move on to adding 0.5 milliliter portions. And it says to do that plus or minus 3 from the equivalence point. And so that would be, we're going to add 0.5 milliliter portions for about 2 milliliters. So if our initial was 5, and then at this point in the 2 milliliter range we added 17, so now we're at 22, we're going to add 2 more, which at 24 is when we stop adding 0.5. And then the next range is when we're adding 2 milliliter portions, or it could even be less, like 0.1. And that's going to correspond to where we are within 1 milliliters of the equivalence point. And again, the equivalence point is going to be roughly around the end point. So now we're going to add 0.2 milliliter portions, and after we do that, we're going to now go back up to 0.5 for another 2 or 3 milliliters, and then we're going to go back to 2 milliliter portions for the next 10 milliliters. This should be a plus here, by the way. Okay, all right, so what do I mean by all of these portions? This is what the data looked like that I did. I did it a little differently. I did this as 1 milliliter portions, and then here these were a little bit smaller. So notice that before you reach around the equivalence points, we have these dots. They're all sort of spread out. We're adding a lot of base in between each ones here. When I say a lot, like the 2 milliliter or 1 milliliter. But then as we get to the equivalence point, we want as many points as possible, because what we're looking for is the sharpest rise in our pH curve, and we can only see that clearly if the points are really close together. And so we we add just a small amount each time here. And then towards the end, we sort of get this sort of spread out curve. We can spread it out again. All right, so that's what we're aiming to do. So initially around 2 or so milliliters. Here we're adding about 0.5, and then we get to like the 0.1s or the 0.2s. 0.2s up here again, 0.5s around here, and then over here we're adding the 2 milliliter portions. All right, so here is the setup. I already have my burette. I'm probably going to have to add some more sodium hydroxide to that. And I have the Erlenmeyer flask, unknown acid, and my distilled water. Let's go ahead and add the unknown acid. I'm supposed to add 3.51. And again, I got that from the previous calculation. I'm just going to pour that in under precise. And so it has been added to the flask. I can go ahead and remove that because I don't need that anymore. Now I'm going to add in my water, and I'm going to add 50 milliliters again. Okay, now I can just remove that. I'm done with that. All right, let me go ahead and check out my base. I don't need phenolphthalein in this case. This is not an indicator situation here. I want to check out to see how much base I have. So back in the stock room, I'm going to get sodium hydroxide. I'm going to pour it over, and then I can see that the volume reading is a little bit above 19. So I'm going to add in about, let's go for like 10 milliliters. I think that should be good. I think that should be enough. All right, and so now my initial burette reading here is, this is 8.5, so that's 8.6. This is 8.7. So I'm going to say it's around 8.70. Okay, I'm going to close that. And that's going to go in my spreadsheet here, 8.70. All right, going back to the workbench, I'm going to remove the sodium hydroxide because I don't need that anymore. And I'm also going to record the initial pH. 2.26 is what the pH is, so I'm going to record that here. So what I'm going to do is I'm going to get a bunch of data for my pH and then the volume of sodium hydroxide. All right, and now in my case, since I'm starting at 8.7, that means I'm going to add 2 milliliter portions until I get to around 8.7 plus, so I'll take that value, 8.7. I'm going to add like about 17 to that. So when I get to around 25, I'm going to stop. If I get to around 25, I'm going to stop adding 2 milliliter portions and bring it down to 0.5 milliliters. Okay, so initial volume plus 17, and that tells me where I'm going to stop adding my 2 milliliter portions. All right, going back to this, I can now start my experiment. So here we go. We're adding 2 milliliter portions, and what I need to do is each time record the volume and the pH. Okay, so I had my first 2 milliliter portion, bam, the pH is now 3.16, and the volume is quite simple since I'm adding it precisely to, I don't really have to keep reading it. So in this case, it's going to be just 8.7 plus 2, which is 10.7. And the pH reading is 3.16. Okay, and I add that to my data. All right, I'm going to add another 2 milliliter portion. I'm going to do this again. And now my pH is at 3.5. And this is at 12.7. All right, so I'm going to keep doing this up until I get to around 25-ish milliliters in terms of the volume of the pH. I'm going to pause the video here, and then when we come back, I'll show you what we do when we get nearer to the equivalent point. All right, welcome back. So at this point, I'm really near the 25 milliliter mark, so I'm going to stop adding 2 milliliter portions, and I'm going to change it to about 0.5 milliliter portions. I'm going to do this 4 times, so for about 4 milliliters, and then I'll reduce it down to the 0.2. All right, so my pH now is 4.7. I'm going to go ahead and 4.71 or 4.7. I'm going to go ahead and pour in 0.5 milliliters. And I notice the pH change. I'm going to do 4.78. And now I need to record the volume. So the volume should be whatever this number is plus 0.5. I'm going to double check just to make sure that is the case. So this is 20, 25.2, 25.12. Looks like it's really close to the 25.20 mark. So that's what I'm going to put down. And that matches when we're adding 0.5 increments, okay? So I'm going to do this 4 more times, and then at the end of that, I'm going to start doing 0.2 milliliter portions. Okay, so I finished adding the 0.5 milliliter portions, and I kind of color coded. This is for the 2 milliliters, this is for the 0.5 milliliters. Now I'm going to reduce the volume, the amount I'm adding, down to 0.2, and I'm going to monitor the pH again. So here's my next set. The pH goes up to 5.12, and the volume here, this is 26.9. It looks like it's slightly below, so between 26.9 and 27, so I'm going to say 26.91. Just a quick note that the volumes should all have 2 decimal places in your own data table. Excel doesn't, or the spreadsheets don't record them that way. So if you put down 27.70, it's going to show up as 27, or 22.70 shows up as 22.7, just so you know, but it should have 2 decimal places. All right, that's enough of that sig fig notes there. So let me record down my pH, 5.12. All right, and I'm going to do this for the next 2 or so milliliters, and I'm going to look out for a big spike in the pH, so that tells me that I am at or near the equivalence point when it spikes up. It hasn't spiked up yet, but it will shortly. So I have completed the experiment. So in these pink portions is where I was using the 0.2 molar sodium hydroxide. I was adding that much to from the burette. And here's something I want to point out to you. And so here, around here, you will find the equivalence point. And what you'll notice here is that there's a huge spike. Notice that the pHs are like gradually increasing, and then all of a sudden there's this huge jump from like 6 to about 11, pH of 11. And so that's my clue that I've reached the equivalence point. So what I did from that point forward, I continued to add 0.2 milliliter portions, and I like things to be even. So I noticed that before this jump, I did about 9.2 milliliter portions, so I did 9 more after. And then I moved into the 0.5, which is in blue, and I did that 4 times, just like I did above, 4 times. And then I moved into the 2 milliliter portions, and in this case, I added in total 12, so I did that 6 times, all right? And so I got all my data here. All right, the last thing we need to do is analyze this data, and we're going to have a separate video for that, show you how to analyze this data, but you now have the data that you need, and this section of the experiment is now over. So you're going to watch part 3 to see how to analyze the data.